The Fortymile is typical of many rivers in the Yukon, which have large flood drainage in the spring, with bars left as water recedes over the summer months. There is gold present in the gravel of these bars. After acquiring mineral rights to the bars of the Fortymile River, we had to develop a mining method to extract the gold out of the bar gravel. The bar which we are mining here is typical of the gravel bar's environmental considerations. This type of dredging was not a feasible option for us. The Fortymile River is considered a salmon rearing river and therefore has high environmental priority. We became interested in a dredging method using a combination of a floating gravel processing plant and a conventional excavator. You can see the gravel processing plant floating in a pond created by groundwater in a pit excavated to bedrock. The excavator is stationed on dry ground in front of the pond. Gravel, excavated from the face at the front of the pond, is fed into the floating processing plant where it is washed and screened. The fine gravel is processed to recover the gold. The oversized coarse gravel tailings are stacked by conveyor in the back end of the pond. A moving, dredging settling pond is created as the excavator digs away the pond face and the tailings stacker deposits waste gravel behind the plant. The processing plant is anchored by winch lines to the shore and is maneuvered in the pond to keep it in front of the excavator. This is a very efficient and cost-effective method of processing placer gravel. As well as allowing us to mine ground with a high water table, this method has a number of advantages. The pond serves for both water acquisition and as a settling pond. Recycling processed water in this closed system results in no effluent discharge to the water course. There is no problem meeting strict discharge standards. The winch lines can be seen here anchored to boulders on the shore. The lines are crossed with the stern of the barge anchored to a boulder in line with the cut face. The bow of the barge is anchored to a point close to the tailings. This triangulation of the lines makes it easy to move the barge and helps keep it in a fixed position in the pond. Moving the process equipment to the gravel keeps haul distances short, resulting in efficiency and lower gravel handling cost. The plant can be moved quickly and easily. We move about every half hour. It takes approximately 2 to 3 minutes to move the plant into position. The mobility of the plant also allows for economic handling of tailings. When a tailings pile reaches the height of the conveyor discharge, the plant is moved sideways in the pond, and a new tailings pile is started. The need for tailings handling using heavy equipment is eliminated. You can see the series of tailings piles left by the plant. These piles will be leveled in order to restore the mine site. The fact that restoration can be achieved cheaply and effectively is both an economic and an environmental advantage of this mining method. The trommel, the conveyor, and the water system are powered electrically from the main generator located on the barge. You can see the orange-colored generator mounted underneath the trommel barrel here. We are using a 35 kilowatt three-phase generator running at 230 volts. This provides ample power with a reserve capacity for auxiliary equipment such as night running lights. The gravel enters the processing system through the hopper. It is set at an angle sufficient to promote an even flow of gravel into the trommel barrel. Spray bars, located on the lip of the hopper, keep the hopper floor slick with water, aiding in the gravel flow. Because the gravel enters the hopper soaking wet, it feeds smoothly. The gravel is rounded and sandy, so that it feeds easily and jam-ups are rare. While the hopper is a simple component of the floating plant, it serves the important function of metering gravel flow in order to promote an even feed into the system. Here we are looking up the trommel barrel towards the hopper. The trommel is equipped with 1/4 inch mesh screen. A spray bar washes the gravel as it makes its way down the trommel barrel. The material less than 1/4 inch falls through the screen to be processed for gold recovery. The washed gravel, over 1/4 inch in size, continues down the trommel barrel to be discharged as waste. Processed water for the gravel is supplied from a submersible 4-inch electric pump mounted on board the barge. This pump delivers approximately 700 gallons of water per minute. The trommel revolves at approximately 14 revolutions per minute. It is driven with a chain and sprocket drive, powered by a 5 horsepower electric motor. This trommel is 4 feet in diameter and 12 feet long. The coarse tailings are discharged from the trommel onto the stacker conveyor belt. The conveyor stacks the tailings well behind the plant in the back of the pond. Our conveyor is 32 feet long and 24 inches wide. The head end of the conveyor is suspended from cables anchored to the plant. It is set at an angle of approximately 20 degrees to the horizontal. The conveyor is driven by a 3 horsepower electric motor close coupled to a gear reduction unit, which is mounted directly on the drive pulley shaft. The slurry of water and fine gold-bearing material, which has been screened by the trommel, is split and fed to a system of sluice cables located on each side of the barge. This arrangement maintains balance. Most of the gold is recovered in the first set of tables. These tables are 6 feet in length. The width flows from 2.5 feet where the slurry enters to 6 feet at the discharge end. These tables are equipped with hydraulic ripples, which work well for recovering fine gold. Low-pressure water is injected into the sluice bed, keeping the bed loose, so that fine gold particles work their way well down into the concentrate. The slurry then enters the second set of sluice runs. They are 4 feet wide and 12 feet long. These runs are equipped with nomad matting and expanded metal riffles. Because the side cables are very efficient at saving gold, there is very little gold captured by the end sluice runs. The barge forms a platform for the processing equipment. Its shape is dictated by the loads imposed upon it. Because the conveyor overhangs the barge considerably, the stern is much wider than the bow in order to handle the weight of the conveyor and its load. It is built of modular sections for ease of transportation and handling. The generous width of the stern, 18 feet, provides plenty of room to accommodate the sluice tables. The narrower bow, which is 12 feet wide, allows the excavator operator to dig close into the plant. The length of the barge is 24 feet, and the depth is 3 feet. Although the total weight of the plant and barge is in excess of 15 tons, it can be moved easily with simple hand winches and common rope. The winches are located at the bow of the barge under the hopper. They are grouped because they must be worked together. For example, when one set of lines are shortened to move the plant, another set of lines must be lengthened. The final stage of the mining process is the leveling and contouring of the tailings piles left by the conveyor. Because the piles left by the conveyor are small, the tailings can be leveled easily by filling the valleys left with the crowns of the piles. When mining is finished for the season, or when reserves are exhausted on a bar, tailings are pushed into the pond to fill it. Once the pond is filled, the restoration of the mined area is complete. This area was mined last year and has gone through a spring breakup of ice scouring and high water. The restored bar is now indistinguishable from an unmined gravel bar. The concept of using a floating processing plant with land-based excavation equipment was used in California in the past and is currently used in New Zealand. We would like to acknowledge the New Zealand miners who took the time to show us their operations. We learned a great deal from them. We hope this video has been useful for placer miners considering implementing this mining method. This completes our presentation.